Well, hey guys, and welcome to the second part of our summary sheet preparation for your upcoming test. So we're going to go through the second page. So on the back page of what you've been creating, we're going to put today's stuff from this video. So this shape up here shouldn't be any surprise to you. This is nothing new. This is what we call a rectangle. So what do we know about the symmetry of a rectangle? Now, symmetry, remember, there's a couple of different types of symmetry. The first one is line symmetry. So if I drew a line down this, I could fold that rectangle in on itself. It would be the same on both sides. That's a line of symmetry. Now, is there another line of symmetry where I could fold this rectangle in half and have it exactly the same on both sides? Well, hopefully you can see there's actually one across this way. Now, not the diagonals, because if I folded the rectangle on a diagonal, they wouldn't line up exactly. So the only lines of symmetry for this rectangle are here, and we say there are two lines of symmetry. But that's not the only type of symmetry. We also have a rotational symmetry. Now, rotational symmetry is when we turn our shape, or we rotate it one whole revolution, 360 degrees. And we're going to count how many times in that revolution it looks exactly the same as it does. So let's do it. Let's start to rotate my rectangle. If I rotate it once, I can see there it looks exactly the same, but we haven't rotated it all the way around yet. So that's one. And if I go back to where I started now, that's two. So twice it looks the same. So I say it has an order of rotational symmetry of two. So twice it looks identical when I do one full revolution. All right, what about congruent shapes? Well, congruent shapes, hopefully you can remember, think of identical twins. So they have exactly the same size and they have exactly the same shape. When two shapes are congruent, they're identical to each other. Same size, same shape. Now, we went out in the car park, I don't know if you remembered in class, and we looked at some parked cars. And the reason we did that is because we're going to get this idea of corresponding angles and corresponding sides. So if I'm looking at a car, it's kind of got, let's say I labeled each of the corners. It's kind of a rectangular shape if I look down on it from above. Now remember, at the pointy bits or at the corners of shapes, we label them with capital letters. So I could label this rectangle, my car here, A, B, C, D. Now what if I had another car that was parked the opposite, or like a different direction, facing a different way? And we're going to call this one W, X, Y, Z at each of the corners. Now, the reason we did this is to highlight this idea that there are corresponding angles and sides. So, what do I mean by that? Well, let's say I took angle A. In other words, the corner A on this car. Now, I can see that that is the front passenger side. If this is the steering wheel where the driver sits, this is the passenger side, and it's the front. So even though this car is facing a different direction, it still has a corresponding side. It has a passenger side front, and you can see that that's this one here. It's the front of the car on the passenger side. So it's the same corner, or it's the corresponding corner to A. So I would say that angle A is equal to angle X. They are the same angles, just facing different directions. We can do the same thing, but with sides. Okay, so what if I said, what's the corresponding side to BC? Well, BC goes from the front driver's side to the rear driver's side, front to back on the driver's side. So on this car, which does the same thing, which goes from front to back on the driver's side? Well, here's the driver's side, there's the front, it goes from front to back, so it goes Y to Z. So BC is corresponding with YZ. Right? Same side going in the same direction. That is important when we start to talk about congruent shapes. Here is a triangle. I could call this a number of different names. I could call it ABC or CAB. I'm actually going to call it BCA, but we'll look at that in a moment. Let's say these two triangles are congruent. Even though they're facing different directions, they're not sort of they're not exactly sort of orientated the same, but they're congruent. So if we're told that they're congruent, then we can make what we call a congruence statement. Let me go through and explain it. Let's name the first triangle. Little symbol at the front to represent that it's a triangle. BAC. So I've called it triangle BAC. Now, if I want to write a congruent statement, the symbol that we use for congruence is this triple equals sign. Okay, so it's like it's more than equal, super equal. Okay, so it's equal, but it's a little bit more equal. So triple equal means congruent. So triangle BAC is congruent to. Now, it's really important the order that we write the letters for this triangle. Just like we did with the cars, we've got to find the matching corners. So let's do it. We're going to write triangle. Now, here we look, I've got my first triangle was starting at the B. That's the pointy bit here, the sharpest angle in this triangle. So I've got to find the corresponding angle on the other triangle. And it's this one here, isn't it? It's the pointy bit. It's the sharpest angle. So it's going to start the name of this triangle with X. Now it matters which direction I go. With this one, we went B to A. So we went from the pointy bit to the obtuse angle here, the one that's more than 90 degrees. So I've got to go to the same point in this one. So I can't go XY because that's not the same angle. I've got to go X to Z. I'm going to the corresponding angle, and then that just leaves me with the other way, so X, Z, Y. So it does matter. If I wrote X, Y, Z, I'd actually be wrong because we've got to go the same sort of pattern. So from here we went pointy, obtuse, and then the acute angle. So we're going to do the same here. Pointy, obtuse, and then the acute. So it matters which way you go. They have to be the corresponding ones. I hope that makes sense. A little bit confusing, but rewind if you need to and just review that. Almost done. Let's go back to our rectangle. What can you tell me about some of the features, apart from the symmetry, which we've already done? What could you tell me about the opposite sides? So this side and this side are opposite to each other. I've got this side and this side opposite to each other. Well, I can look at that and I know that the opposite sides are equal in length. The little mark tells me this side and this side are the same length. The double mark tells me this side and this side. So opposite sides are equal. What else could you tell me about the opposite sides? If you look at a rectangle, this pair of sides and this pair of sides are both parallel to each other. So in a rectangle, opposite sides are parallel. And last of all, what could you tell me about the opposite angles? Well, because it's a rectangle, I know that each of these angles is 90 degrees. So what do we know about the opposite angles? That angle is the same as that angle. That angle is the same as that angle. So opposite angles are equal to each other. Guys, that is it for this part 2 video. If you can copy down everything you see on the screen onto your summary sheet, and I'll try and give you some practice questions that you can apply some of these ideas to. We've talked about symmetry, we've talked about congruent shapes, we've talked about corresponding sides and angles, a congruent statement, and some features about rectangles. Good job, well done.